See, in this chapter I am going to discuss with you about plane polar coordinate system. Though this is not directly mentioned in the syllabus, but still I am discussing it, right? See, you have read about Cartesian coordinate system. See, when you have two-dimensional coordinate system, suppose we have, usually your question comes in two dimension. There are in fact two very famous kind of two-dimensional coordinate system. One is Cartesian coordinate system, and the other is plane polar coordinate system. One is Cartesian coordinate system, other is plane polar coordinate system, right? Cartesian coordinates. You all know what is Cartesian coordinate. In Cartesian coordinate, you have two axes. One is x-axis, one is y-axis. This is x-axis, this is y-axis. And if you have any particle in space, if you have any point in space, the position of that point is denoted by assigning two coordinates x and y, where x is distance of this point P from the y-axis and y is distance of point P from the x-axis. X is distance of point P from the y-axis and y is distance of this point P from the x-axis, right? We assign these two coordinates. And in vector terms, we define position vector as xi cap plus yj cap. Xi cap plus yj cap, right? Where I cap is unit vector in direction increasing x and j cap is unit vector in direction of increasing y. I cap is unit vector in direction of increasing x and j cap is unit vector in direction of increasing y. Getting your point? I cap is unit vector in direction of increasing x and y cap is unit vector in direction of increasing y. Alright. So they are unit vectors. I cap, j cap, they are unit vectors and they are constant vectors also. Wherever you take this point, if you take point P over here, there also this is I cap and this is j cap. So since the unit vector, their magnitude is 1 and direction also is same. Wherever you choose this point, I cap is and j cap, direction of I cap and j cap does not change with time. So velocity is what? dr by dt. So if I take derivative, then we have x dot I cap. Since I cap and j cap, they are constant vectors. So derivative of I cap and j cap are 0. So we will take derivative of x and y only. And this is called Vx dx by dt. X dot means Vx by dt, dx by dt, and y dot means dy by dt, which is Vy. And acceleration will be what? Acceleration is going to be dv by dt. So that will be x double dot I cap plus y double dot j cap, right? X double dot I cap plus y double dot j cap. This is how we write position, velocity and acceleration in case of Cartesian coordinate system. So we have seen in Cartesian coordinate system, you have two axes x and y and the point of intersection is called origin, and if you take any particle in space, that position of that particle can be described by assigning two coordinates x and y, where x is distance from y, distance of point P from the y axis, and y is distance of that point from x axis. And we write the position, velocity and acceleration like this. We define position, velocity, acceleration like that. Here I cap and j cap, they are unit vectors and they are constant vectors also, because their magnitude and direction both remain constant wherever you choose this point P, right? In case of plane polar coordinate system, you don't have x and y axis. You have an origin. We have an origin and initial line. See, this is your origin and this is initial line. Get your point? This is your origin. This is origin. And this line is called initial line. Got it? Initial line. And if you have any particle or any point in space, then position of this point or particle, it can be particle or it can be point, position of this point or particle is represented by assigning two coordinates r and theta, where r is distance of point P from the origin, where r is distance of this point P from the origin, and theta is the angle which this r makes with the initial line. Theta is the angle which this line makes with the initial line. Get your point? So we can describe the position of any point P in space by assigning two coordinates r and theta, where r is distance of point P from the origin and theta is the angle which this r makes with the initial line. If this angle is anti-clockwise, we take it as positive, and if it is clockwise, we take it as negative. Get your point? If I have any point on this side, then this is going to be r and this is going to be theta, then this theta will be taken negative. If it is 30 degree, I will take theta as minus 30. If it is 45 degree, I will take this theta as 45 degree. On this side it is positive, that's convention, and on this side is negative, right? Okay, so we take these two coordinates to describe the position of any point P in space. And now there are two unit vectors. One is unit vector in direction increasing r, that is ER, and you have a unit vector in direction of increasing theta. ER is unit vector in direction of increasing r. Increasing r means this is r, and this is unit vector in direction increasing r. E theta, that's unit vector in direction increasing theta. This is theta, and your unit vector in direction increasing theta. Unit vector in direction of increasing theta. Unit vector in direction increasing theta, that's E theta. That's E theta. Alright? Okay. So that's how you describe the position of any point P in plane polar coordinate system. Now the position vector of this point P can be given by, so you have position vector is given by, this is the unit position vector, this is the position vector r, and this r, what is the magnitude of r? Magnitude of r is r, and direction of r is, that's lying in direction of ER. So position vector can be given by this. The unit vector, this ER, lies in direction of position vector. So magnitude of this position vector is r, right? And direction of this r vector is same as ER. That's the magnitude, that's the direction. Every vector can be written as its magnitude into unit vector in that direction. So that's your r vector. What's the velocity? Velocity is simply dr by dt as d by dt of r here. That is and this is this. Alright, so this is your r dot here, and what's this thing? See, remember, see, unlike this I cap and j cap, this unit vector ER and it are not constant vectors. I cap, j cap used to be unit vector as well as constant vector because its magnitude is 1 and direction also remains same. But this ER and E theta, the magnitude is always 1 because they are unit vectors. But the direction of ER and E theta depends on point P. If I take point P here, if I take point P over here, then this is going to be r, and your ER vector is going to be this direction, and this is theta, so E theta vector will be in this direction. If I take point P over here, Then in that case, this is going to be ER vector. And it says theta, E theta vector is going to be this. Get a point? So ER and E theta. So ER and direction of ER and E theta, this ER and this ER is different. They have got different direction. So direction of ER and E theta always depends on the choice of point P. Choice of point P. Right? Wherever you take this point P, that will decide what is direction of ER and E theta. First you have to join that point with the origin, and then you get R, and then in direction increasing R you have ER vector, and direction perpendicular to R, that is E theta, right? E theta lies perpendicular to ER vector. So these are orthogonal unit vectors, and in case of plane polar coordinate system, these two vectors are not constant vectors. They are unit vectors. They are unit vector. Their magnitude always remains same, but the direction depends on the point P. So the thing is that we have to find this dEr by dt. We have to find this dEr by dt, right? Let's try to do that. Let's try to find this dEr by dt. See, there are several ways of doing that. I'll tell you most innovative and very easy way of doing this. People do it in a big way also. In a derivation can be lengthy also, but I'll tell you the shortest possible way of getting dEr by dt and also d theta by dt. Alright. See, in mathematics there are three ways of representing any point in space. One is assigning coordinate, other is in terms of vector, and the third very innovative and very good way of representing position of any point in two-dimensional space, and that is complex number. You know, complex number. Say this point can be represented by this complex number equals to REI theta. REI theta, right? Where R is the magnitude, say this, and EI theta is just like ER. Here, see, you represented this point by position vector, this. So in fact, if you see this, your ER is analogous to EI theta. See, the magnitude of ER is 1, the magnitude of EI theta is 1. See, this is your ER. If I want to draw ER vector, this is ER, and if you want to draw EI theta means what? A complex number whose magnitude is 1 and lying at an angle of theta. This is complex number which is represented by EI theta. So ER is analogous to EI theta in a way, right? So if I and what about E theta? Say if this is your EI theta, this is your EI theta, then what is this? This is going to be, this is EI theta, then this E theta is analogous to what? EI theta plus pi by 2. You know this. You have read complex numbers. If you have not read, you must read it. This is EI theta, then E theta would be EI theta plus pi by 2. Now, dEr by dt is what? IEI theta d theta by dt. And what is I? See, I must tell you one thing. EI theta is cos theta plus I sin theta. So EI pi by 2 is I, that is and theta dot is d theta by dt is theta dot. So this will be EI, and what is this? This is same as E theta. Same as E theta. Get your point? So what do you find? You find that d by dt of ER is theta dot E theta. Moreover, there is a very important theorem in vector algebra that says, theorem is, if A is a vector of constant magnitude, then A dot dA by dt is 0, which implies dA by dt is perpendicular to A. We can prove it very easily. If magnitude of A is constant, that means what? The square of magnitude is constant, and square of magnitude is given by A dot A. So if I take derivative, that will be 0, and this is dA by dt dot A and A dot, right, and this is what? Twice of, see, dot product of A is dot product of two vectors are commutative. A dot B is B dot A. So this is dA by dt dot A is A dot dA by dt. So it will come like this, and from here we get an idea that A dot dA by dt is 0, and that implies that if A has got a constant magnitude, then its derivative is perpendicular to A. Then its derivative is perpendicular to A. Alright, and same thing is happening over here. ER is a unit vector, so it has got a constant magnitude. Wherever you take point P, ER is a vector of constant magnitude, so its derivative is lying in direction of E theta. See, it is derivative of ER is perpendicular to ER, and it's lying in direction of E theta. That means derivative of ER is perpendicular to ER. E theta is perpendicular to ER. So derivative of ER lies in direction of E theta. It can be in direction of E theta. So of course E theta is perpendicular to ER. So this is perpendicular to ER. So dER by dt is perpendicular to ER. Similarly, we can find out derivative of E theta also. E theta is analogous to this complex number. So this is d by dt of, right? So this can be written as I theta dot. And see, one more thing. In Euler form we have seen that EI theta is cos theta plus I sin theta. That implies EI pi by 2 is what? EI pi by 2 is cos pi by 2, and this is 0, so this is I. So I is EI pi by 2, and one EI pi by 2 will come from here also, and that will give you EI pi, and EI pi is what? If you put pi over here, it will be cos pi plus sin pi, so it will be minus 1. So minus 1 theta dot EI theta, and EI theta is analogous to ER. So these two are very important relation. One is your dER by dt is theta dot E theta, and d theta by dt is minus theta dot ER. Moreover, from this equation and from these two relation, we can find the expression of velocity and acceleration plane polar coordinate system. See, position is given by RER and velocity is dr by dt, that is d by dt of RER and d by dt ER right. So this is R dot, which is called radial component, and this is R theta dot d theta. So this is radial component and this is transverse component. This is called radial component and this is called transverse component. Suppose this is origin as initial line and some body is moving like this, and at this point we want to find what is the, suppose at this point we are interested in finding the radial and transverse component. Suppose the body moves like, say, on this path, suppose. Getting a point? So if the body is moving in this on this path, then of course if I am interested in finding out the velocity at this point, then if you are given a path, the velocity is always tangential to the path, and I want to find radial and transverse component, then you see you have to join this point from the origin, then this is your ER as your E theta, right? So if this angle is a theta, then this velocity has got a, see, this velocity has got a radial component V cos theta, and perpendicular to this is R. So the component which is along R is called radial component, and the component which is perpendicular to R will be transverse component. So we can write this as the velocity in radial direction would be, since it is in opposite, it is in direction opposite to ER, so I write this V as V cos theta, and this velocity is lying opposite to ER, so minus ER cap plus V sin theta, it is in direction of E theta, so we write like this. So you can say minus V cos theta ER. So anyway, this is R dot, this is R theta dot. This is R dot, this is R theta dot. If I given R and theta, you can find the velocity. Right? So this is called radial component, this is called transverse component. This is R dot radial component, this is transverse component. You can find the acceleration also, expression of acceleration also. The expression of acceleration is, let me give you the expression of acceleration also. It's a bit difficult, it won't be useful for you, but I'm just writing it over here so as to complete this topic. This is important for you. We will make use of this in circular motion and gravitation. We will make use of this expression in circular motion and gravitation, but just for the sake of completeness I am finding out acceleration also. So this is what, if I take a derivative of this whole thing, then this is R double dot ER, then you have R dot d by dt of ER, then you have R dot theta dot E theta, then you have R theta double dot E theta, and then you have R theta dot d by dt of E theta, right? So that can be written as R dot ER, and dER by dt we have already found. So see R dot theta dot E theta, so R dot theta dot E theta, and this is R theta double dot E theta, and this is R theta dot minus of theta dot ER. And let's correct all the terms, ER terms and E theta terms. This will be R double dot minus R theta dot square ER, and 2R dot theta dot plus R theta double dot E theta, or this is R double dot one by R d by dt R, right? You write like this. This is radial component, and this is transverse component. Radial component and transverse component. Acceleration radial direction and acceleration transverse direction. Getting a point? This is how we can do it. This is how we can find the acceleration. We can find the acceleration. Okay. So should I stop over here? I'll make use of this. Okay. Thank you very much.